For thousands of years, humanity believed the edge of the known world ended at the horizon. Every generation pushed that boundary a little farther, discovering new continents, new oceans, and eventually new planets. Yet no explorer has ever traveled farther from Earth than a small robotic spacecraft launched nearly half a century ago. That spacecraft is Voyager 1. When it lifted off in 1977, its mission was surprisingly simple. Engineers expected it to spend only a few years exploring the giant planets before its work came to an end. No one imagined that decades later it would still be operating, carrying humanity's curiosity into a region of space no civilization had ever explored. Today, Voyager 1 is more than 15 billion miles from Earth, traveling through the vast darkness between the stars. Every signal it sends has crossed billions of kilometers before reaching the giant antennas of NASA's Deep Space Network. Those faint transmissions are among the weakest radio signals ever detected, yet they continue to reveal an environment unlike anything scientists expected. Before Voyager reached interstellar space, it transformed our understanding of the outer solar system. As it rushed past Jupiter, the spacecraft revealed a world far more violent than astronomers had imagined. Towering storms larger than Earth churned endlessly through the planet's atmosphere. Lightning flashed with unimaginable power, while intense radiation surrounded the giant planet like an invisible shield. One of the greatest surprises waited on Jupiter's moon Io. Scientists once assumed distant moons were frozen, lifeless worlds. Instead, Voyager photographed enormous volcanic eruptions blasting molten material hundreds of kilometers above the surface. It was the first active volcano ever discovered beyond Earth, proving that the solar system was far more dynamic than anyone had predicted. The mission continued toward Saturn, where Voyager captured breathtaking images of the planet's magnificent rings. What looked smooth through telescopes was actually an intricate system made of countless icy particles orbiting together with remarkable precision. The spacecraft also examined Saturn's largest moon, Titan. Hidden beneath a thick orange atmosphere, Titan hinted that complex chemistry could exist far from the warmth of the Sun. Those early observations inspired decades of future exploration. With its planetary mission complete, Voyager 1 began a journey no spacecraft had attempted before. Instead of turning back, it continued outward toward the invisible boundary surrounding our solar system. This enormous region, known as the heliosphere, is created by the continuous flow of charged particles streaming from the Sun. For billions of kilometers, this solar wind forms a protective bubble that shields our planetary system from much of the high-energy radiation traveling through our galaxy. For years, scientists believed this boundary would be relatively smooth. They expected Voyager to cross a clear dividing line separating the Sun's influence from interstellar space. Reality turned out to be far more complicated. As Voyager approached the edge of the heliosphere, its instruments detected rapidly changing magnetic fields, shifting particle densities, and turbulent regions where solar material collided with matter drifting between the stars. Rather than a calm frontier, the boundary resembled an active ocean filled with invisible currents and waves. Then, in 2012, Voyager 1 crossed the heliopause, becoming the first human-made object ever to enter interstellar space. This historic milestone marked humanity's first direct exploration beyond the Sun's protective bubble. Instead of silence, Voyager encountered a surprisingly active environment. Galactic cosmic rays became far more intense. The influence of the solar wind weakened dramatically. Invisible magnetic fields stretched across interstellar space in patterns that researchers are still trying to understand. Among the spacecraft's most valuable instruments was its plasma wave detector. Although space is nearly empty, it is not a perfect vacuum. Thin clouds of electrically charged gas, called plasma, drift between the stars. As shock waves from distant stellar explosions travel through this plasma, they create subtle vibrations. Voyager measures these oscillations with extraordinary sensitivity. Scientists can even convert these plasma vibrations into audible frequencies, allowing us to hear the invisible structure of interstellar space. The sounds are not voices or mysterious transmissions. They are natural signatures created by charged particles interacting with magnetic fields across enormous cosmic distances. These measurements revealed something remarkable. The space between the stars is not empty. It is filled with invisible energy, constantly shifting magnetic structures, and streams of particles moving across the galaxy. Every new observation challenged the long-held image of deep space as a silent void. Meanwhile, Voyager itself continues an incredible battle against time. Its electricity comes from a radioisotope power system that slowly loses output every year. To keep the spacecraft alive, engineers have carefully switched off one scientific instrument after another, preserving only the systems considered most essential. Each remaining watt of power is carefully managed. Despite being built with technology less powerful than a modern calculator, Voyager continues sending priceless scientific information from a place no human has ever visited. As Voyager 1 traveled farther into interstellar space, every transmission arriving on Earth carried information from a place no spacecraft had ever explored before. Scientists expected the environment beyond the heliosphere to be relatively quiet, but the data revealed a far more complex picture. One of the biggest surprises came from the behavior of interstellar plasma. Instead of remaining smooth and uniform, the plasma surrounding Voyager constantly changed. Its density fluctuated, magnetic fields shifted direction, and waves of charged particles passed through regions once believed to be nearly empty. These changes were not random noise. Each measurement provided valuable clues about the invisible structure of our galaxy. Powerful shock waves produced by distant stellar explosions traveled across interstellar space, compressing the thin plasma around Voyager and creating measurable oscillations. By studying these patterns, researchers could estimate the density of matter between the stars with remarkable precision. At times, Voyager's instruments recorded repeating plasma wave signatures that attracted scientific attention. These signals were unusual, but they were entirely consistent with natural astrophysical processes. As shock fronts moved through the interstellar medium, they disturbed the surrounding plasma, producing organized wave patterns that could be detected by Voyager's sensitive instruments. Although these observations inspired dramatic headlines, NASA has never reported evidence of artificial transmissions or extraterrestrial messages. Instead, the spacecraft has demonstrated something equally extraordinary. The region between the stars is alive with invisible activity. Magnetic turbulence, cosmic radiation, and plasma interactions shape an environment that is constantly evolving across enormous distances. Meanwhile, keeping Voyager operational has become one of the greatest engineering achievements in space exploration. Its radio transmitter now operates with only a tiny fraction of its original power. By the time its signal reaches Earth, it is unimaginably weak, requiring enormous radio antennas and highly sensitive receivers to detect it. Even a slight misalignment of Voyager's antenna could interrupt communication after billions of kilometers of travel. Engineers carefully monitor the spacecraft, sending commands that take more than 20 hours to arrive. Another 20 hours pass before a reply can return, meaning even the simplest adjustment requires nearly 2 days to confirm. In recent years, mission controllers have occasionally encountered communication problems. Unexpected telemetry readings, temporary data corruption, and software anomalies have required creative solutions from engineers working with hardware designed nearly 50 years ago. One widely reported incident involved corrupted engineering data that initially appeared mysterious. After careful investigation, Scientists traced the problem to the spacecraft's onboard computer rather than anything occurring in interstellar space. The successful recovery demonstrated not only the durability of Voyager itself but also the remarkable expertise of the teams still supporting the mission decades after launch. Even as its available power continues to decline, Voyager remains humanity's only direct observer beyond the Sun's protective boundary. Every scientific measurement improves our understanding of cosmic rays, magnetic fields, and the interstellar medium surrounding our solar system. These discoveries are helping researchers build more accurate models of how stars interact with the space between them and how stellar winds shape the structure of entire planetary systems. Perhaps Voyager's greatest contribution is not a single discovery but a new perspective. Before this mission, interstellar space was often imagined as an empty vacuum stretching endlessly between distant stars. Voyager has shown that this picture is incomplete. The galaxy is filled with energetic particles, invisible magnetic fields, and subtle plasma waves that connect distant regions of space in ways scientists are only beginning to understand. One day, Voyager's power source will finally become too weak to operate its remaining instruments. Its final transmission will arrive on Earth, and after nearly half a century of exploration, the spacecraft will fall silent forever. But its journey will not end. With no atmosphere to slow it down and no destination to stop it, Voyager 1 will continue drifting through the Milky Way for millions of years. Attached to its side is the famous Golden Record, a time capsule containing sounds, music, greetings, and images from Earth. It was never intended as a message expecting a reply. Instead, it serves as a symbol of humanity's desire to explore, discover, and share its story with the universe. Whether another civilization ever finds Voyager is impossible to know. What is certain is that its legacy has already transformed science forever. It proved that humanity could build a machine capable of leaving the solar system, surviving for decades in one of the harshest environments imaginable, and continuing to expand our knowledge long after its original mission had ended. Voyager 1 has not uncovered evidence of alien civilizations or mysterious cosmic messages. Its true achievement is far more profound. It revealed that the universe beyond our solar system is richer, more dynamic, and more complex than anyone once believed. And as the spacecraft continues its silent voyage toward the stars, it reminds us that every new frontier begins with a single question, and that the greatest discoveries often lie beyond the edge of the known.